Renata, just wait 30 more seconds because we're gonna wait for everybody to pour in from the other chat rooms.
Oh, it's okay. We'll cut it out in the editing.
Good. I'm gonna wait until it's 31 before I announce what's gonna happen.
Yeah.
Thank you for helping, Renata. You've been very, very good. And we got to the last session of the last day.
Yes, we survived.
We made it.
Yes, and thank you for being such a understanding chair.
You must be joking. You must be joking.
It's a lot of work, so thank you.
Thank you also to you, Jennifer, for being here way in advance of the time that you were scheduled at. All right, guys, let's get started. This is session number 5 of the 4th day of FDG, and it's the last one for me and almost for everybody because we're currently running the last session, and then we're just going to have some closing statements by the general chairs. So as per all the other sessions, we are having 4 talks in this, well, let me repeat again, session. 2 of them are going to be full papers by 15 minutes each, and 2 of them are going to be short papers by 10 minutes each. Renata informed me that the short papers are actually videos, meaning that only in the first 2 occasions I might intervene and interact with the speaker in case she or he goes on for too long. So without further ado, there is the first paper coming up, which is by Jennifer Villarreal, Colin F. Beamer, Maggie Saif El Nasser, and Jichen Zhu. They're either from Drexel University or Northeastern, and the title of the full paper is Reflection in Game-Based Learning, a Survey of Programming Games. Take it away, Jennifer.
All right, thank you. Let me share my screen. All right. Can you guys see my screen? All right. Hello, my name is Jennifer Villarreal, and I'm a PhD candidate in digital media at Drexel University. So on behalf of my co-authors, I'll be presenting our work, Reflection in Game-Based Learning, a survey of programming games. So in our work, we examine educational programming games and analyze how reflection is currently being supported. So we provide a first step towards identifying common reflective design features used in these games to develop an understanding of how to better facilitate player reflection through game design. So let's first start talking about reflection and its impact on learning. So researchers have defined reflection as a process where one engages in an exploration of experiences that lead to new understandings and appreciations. So it's really a cycle of thinking and doing. So when people reflect, the otherwise implicit knowledge becomes digested through active interpretation, questioning, and exploration. So reflection is certainly an active topic in learning science research, and it's widely accepted that reflection is not only beneficial, but also very necessary for learning. So there are 3 common approaches in educational games that I'd like to highlight. And the first approach is to leave reflection to post-gameplay assessments or debriefs. So really showcasing, here is what you did, which usually occur again separately from gameplay. However, learning science researchers say that reflection is very difficult to do, and it takes a lot of effort to really have people reflect on what is important. So these researchers argue that without elaboration or guidance on what is important, just displaying information may not be enough to encourage this behavior. Second, these post-gameplay assessments, they often provide scores or evaluations to measure the correctness of gameplay. While this may certainly encourage reflection, the focus remains on accuracy over the learning process. So the individual's learning process is really essential to increase the learner's awareness of their own learning instead of focusing on if they got the correct answer or not. So reflective practices are especially important in an environment where there exists more than one approach to solve a problem. So for example, in computer science education, novice programmers, they must focus less on the correctness of their solution and more on developing their reflective skills on their process. In this way, they can improve their ability to solve new and unforeseen problems. And then thirdly, reflection is very much a cognitive process. What may encourage me to be reflective may be very different to make what you reflect. So current design approaches, they incorporate catch-all features that generalize reflection. So there's a significant opportunity for personalization here. Moving on, we conducted an exploration of 12 programming games and explored what features currently exist that stimulate reflection. So we utilized two really helpful frameworks, and the first one is Lin et al.'s 4 reflective design features to help us identify what reflective elements are occurring in our 12 games. And these features are derived from learning technology that specifically aim to encourage reflective behaviors. So it was actually very easy to transfer into a game context. His features include process displays, process prompts, process models, and social discourse. So to save a little bit of time, I will define these as I go through our results. And then the second framework we used was Donald Schoen's in-action and on-action framework to specify when these features were occurring, either during gameplay or after gameplay. So Schoen defines reflection in action as the process of revisiting practices during an action and using those results to drive the next action. And then reflection on action is this process of reviewing or analyzing a situation after an event. So Schoen really describes that both of these processes feed into each other and create a cycle of reflection during and after an event. So we selected these 12 programming games based on our previous work in the area and popularity identified with web searches. And we collectively played each game and analyzed the games based on the reflection frameworks described in the previous slide. So next, I'll go into our results and discuss our findings. So the first feature is process displays, and they are displays that visualize problem solving and thinking processes. According to Lin, this feature records learners' actions inside the environment and then visualizes these back to the learner so they can examine them. So 11 out of 12 games provided a display that visualizes the player's solution in the context of the game environment. So for example, in Code Combat, players write code to command a hero through a variety of really cool battles. So when the player is finished writing their code on the right, the player can hit run to see their hero enact the written code on the left. And additionally, the code in the game is highlighted line by line, which really steps the player through their solution. The second feature is process prompts, and these are UI elements such as pop-ups, windows, or pages in a digital interface that poses questions to encourage learners to reflect on a specific area, and sometimes requiring them to explain their actions. So we found that the most common time for these prompts to occur was on failure. So 7 games used prompts to draw attention to an error in the player's code. However, no prompts were used to pose any questions. Rather, it was just highlighting what needed to be fixed before moving on to the next level. So to continue the Code Combat example, if the system encounters an error in the code, a pop-up message appears alongside the incorrect code as seen in the image. And the third feature is process models, and they're displays that showcase experts' thinking processes so learners can compare and contrast with their own process. And we found that 3 out of the 12 games used a form of process models to facilitate reflection on another player's solution. So we saw this occur in 2 ways. First, through a leaderboard, usually outside of the game environment on a website related to the game. And then second, we also found this occur through a comparative stats menu. So for example, in Space Chem, the image you're seeing here, players are building chemical molecules by programming a variety of components. And then it uses a form of process model by showing the player histograms after they've completed a level, which display the player's gameplay stats against the general average to show where the player stands in comparison with others. So these aren't really providing expert answers, but they provide players with a compare and contrast opportunity that really encourages the player to revisit and possibly improve their solution. And then the final feature is social discourse. And this is a space in the interface for community-based discussion where learners can review multiple perspectives and receive feedback on their process. And we found that 5 games use a social discourse feature in the form of a discussion board, but more often, again, it's on the external website where players can discuss their solutions or ask questions. None of the games we analyzed incorporated an area for discussions inside of the game. However, there is only one game, Code Spells, provided a social feature. In this game, players are writing code to act within the game world, such as coding a variety of spells. And they incorporated a social feature where players could share code through a public code library, which allows players to examine or use or even build off of some of these different approaches. All right, now I'll discuss what common reflective patterns we found and open areas for future work. The first pattern we observed from our analysis was that very few games had reflective features during gameplay, and more often they occurred after gameplay. As a result, supporting the whole process of reflection, especially during gameplay, is a significantly underexplored area in programming games. So the design choice may be to indicate designers just don't want to overwhelm or interrupt the gameplay experience, as some of the more complex puzzle games require a significant amount of thinking. However, by not considering reflection features during gameplay, players may be more inclined to only focus on getting the answer correct and then moving on, as opposed to building an effective solution. So more work is really needed to see how we can incrementally guide players' reflection. So reflection support is especially needed in programming games. So as a solution may work in one setting, but may not always work in a new context. So encouraging more frequent feedback during gameplay may help draw attention to the learning process. The second pattern was that we observed all reflection features were confined to a local level-by-level content. So none of the features we surveyed provided a higher viewpoint for players to reflect on their actions across multiple levels or multiple problems. By visualizing this, by visualizing the player's gameplay over numerous levels, it may provide more opportunities for players to really look at their behaviors as a whole. And then the third pattern we observed was that the reflection features were always consistent for each player. So this consistency certainly provides a cohesive player experience, but does not address the differences in reflection. So for example, a process prompt may encourage reflection in one player, but it may not in another. So exploring multiple forms of reflection is really an underexplored area and should be looked at further. So to conclude, the game design and research community can really benefit from more knowledge of how to facilitate and how to support reflection and action, encouraging this incremental thinking and doing on the player's learning process, and then supporting multiple forms of reflection. And thank you all so much for listening, and that completes my presentation. Hopefully it was on time. Thank you. I wanted to count how many times I said the word reflection, but I was a little scared to do that, so. Thank you. Yeah, I'll be on Discord, so if anyone wants to chat about reflection, but you know, I'm around. Which game is the best for reflection? That's a good question. I'm not sure. I feel like I think Code Spells was probably one of my favorites because there's a lot of opportunities to, you know, review other perspectives on codes and, you know, build off of codes. There was a really cool social feature there that I think was probably the most interesting.
All right, I have a question if we still have time. I've thought of one. So then, do you have any thoughts on? So, for example, you mentioned you don't. Maybe some designers don't want to get away from like the core gameplay with adding in all that reflection sort of like in game. So, do you have any thoughts on how you might sort of keep the flow state whilst also providing that sort of reflection in action?
That's a really good question and so difficult to answer. So yeah, I feel like, I mean, you don't want to interrupt the player. That makes a lot of sense. But there comes a time where you have to help maybe guide reflection on making sure that the player is looking at or thinking about their process. So I think that there's a balance there. That balance, I'm not really sure what it is yet, but hopefully in future work I can play around with that some more. So I think it's just, framing things to making sure that the player is focusing on, okay, how am I building this, as in, I just want to get this correct.
I wonder if I thought it's just gone out of my head. I wonder if it's about setting the players' expectations, before they really get into the game. So, I think yesterday I was watching a bunch of stuff on sort of like, I don't know how they call it, like slow games, sort of like making players take a step back and then just like appreciating what they're doing and what they're thinking and everything. So maybe it's just a case of carefully showing the players this is what the game is really about. It's not about speed running it. It's about thinking critically and the rest of it.
Yeah, for sure. I think Code Spells did a really cool thing where they had this public library where you would show, if we could maybe use that to frame, okay, post up different solutions to the same problem, like really setting the expectation, like that is the leaderboard, or that is how you get on, you can share your code. Like again, setting expectations, I think is a great idea. And that, yeah, for sure.
Guys, sorry if I interject. We had a blackout here, so all the chairs fell down and we just got back into the internet in this very moment, which is also lucky because it's time for us to move to the second talk of this session. Thank you very much, Jennifer, and I'm sorry for having missed half of your talk. I was really looking forward to it because I sometimes read Sean for my own stuff. However, okay, so we're moving on to talk number 2, which is another full paper. So it's going to be a 15-minute, let's say, bundle together with questions and answers. The paper is titled "A Visual Novel Route to Learning: A Taxonomy of Educational Visual Novels," and it hails from the University of Santa Cruz with the speakers Jenlyn Kaminge, Edward Meltzer, and Elin Karstendotter. Who's here? Jenlyn, I suppose?
Yep, I'm here.
Yes, okay. Take it away. Thank you very much.
Mm-hmm. Okay.
It says loading. All right, you should be almost there.
Wrong slide.
Great. Thank you.
Okay. I know you all got spoilers. Okay. How about... Okay, can you all see my slide?
Yes, it's very clear, full screen, ready to go.
Awesome. Okay. Hello there. So I'm Janelyn, and I will be presenting a visual novel route to learning, a taxonomy of teaching strategies in visual novels. This is research that was done under the supervision of my advisors, Eddie and Ellen. So these are non-educational visual novels. Visual novels as a genre are very popular, with over 27,000 visual novels recorded on VNDB, a community-managed database for visual novels. Visual novels are on all major platforms and even have their own dedicated game engines. So visual novels are not only popular, but also simple to play and accessible to groups outside mainstream gaming, inclusive of many different groups and topics outside of the mainstream, and are well suited for learning. Which brings us to educational visual novels that teach everything from cooking to even fictional languages. However, educational visual novels are broadly understudied. We have not found many studies on what learning strategies designers employ in educational visual novels, nor of their effectiveness, as existing data is very limited. The way in which the learning strategies are implemented into the design of the visual novel is particularly important. Poorly designed visual novels can be ineffective and present unnecessary confounds that lead to confusion and extraneous cognitive load. This means bad design choices from not understanding the affordances of the genre can hurt educational outcomes. To contribute to solving this problem, the researchers have created a taxonomy to help identify effective existing teaching strategies used by educational visual novels. While there have been studies on educational visual novels, most focus on a single visual novel and its results. For example, the figure shown here illustrates how one visual novel aims to teach new behaviors. Our work instead focuses on educational visual novels as a whole. It builds off of earlier work on progression mechanics in interactive narratives. It also ties in with existing educational research, for example, the conversational framework. So, how did the researcher create the taxonomy? Well, it all begins with one lonely researcher who then goes on a journey to play educational visual novels and then records their gameplay experience and the game's mechanics. This data is then clustered and used to create concepts and themes. We're aware that one researcher may not be enough to account for different playstyles, but however, we address this in our process. The issue of only having one researcher was addressed by following an iterative process. Each week, the researcher played the game, recorded specific mechanics, dynamics, and aesthetics, clustered the data, and discussed the results in weekly meetings with 2 other researchers. Of course, a data set of visual novels had to be established before this process even began. The games in the data set came from a variety of places, from both academic papers like those found in FDG and on digital platforms like Steam and itch.io. This search resulted in 31 games. The researcher used the search term educational visual novel and relied on community-identified tags. The good thing about self-identified tags is that it's public. This means that it can reflect the opinion of both the community and the publisher without bias from the researchers. But the bad thing is, it's public. This means dealing with joke tags and other noise when identifying educational visual novels. This process resulted in a lovely taxonomy of 5 different novel teaching routes or strategies used in visual novels. We have teaching through scripted sequences, teaching through choices, teaching through mini games, teaching through exploration, and finally, non-interactive teaching. In total, 31 games were examined, and scripted sequences was the most popular strategy, but many games used multiple strategies together. The first route we can take in our taxonomy is teaching through scripted sequences. In this strategy, players usually have to follow an exact set of choices or actions in order to progress in the narrative. For example, in the game Code Romantic, the player has to select the correct syntax for each line of code in order to progress. Scripted sequences was by far the most common strategy and draws upon the notion of structured inquiries in the classroom. In this method, students and players learn by following along. Now comes the choice. In the strategy Teaching Through Choice, Players learn through choices. More specifically, players learn by experiencing the story consequences. In the game Kitty Clinic, I'm clearly failing to help my patient socks. However, eventually, after a few replays, I learned how to help socks. Teaching through choices fulfill the autonomy and competence factors for motivation in self-determination theory. This in turn may contribute to higher engagement and better learning outcomes. Minigames are a tool used in many educational games, and visual novels are not an exception. When teaching through minigames, visual novels present players the opportunity to practice concepts. For example, in kanji combat, players are given a chance to review their knowledge of kanji and use it to fight. Traditional game mechanics, such as those employed in minigames, have been extensively studied and can map well to learning and assessment mechanics. In teaching through exploration, players progress in the story and gain knowledge by exploring the fictional world of the visual novel. In this game, Osiris, the player can explore the desert and click on items to learn more about them. So this strategy is similar to the guided inquiry, and in the classroom, a teacher might ask students to design an experiment to answer a question. But in a visual novel, players might be asked to explore a fictional environment to complete some goal. Finally, non-interactive teaching relies solely on narration and dialogue. This teaching strategy follows the transmission model of education. In this game, Benthic Love, the player learns more about the ocean species through dialogue and narration. Scripted sequences can turn into scripted disasters. We found that scripted sequences can be quite a design challenge, and in particular, if the player is not motivated by story consequences, they may skip the educational content. For example, in Gochi Show, your classmate here asks you to crack an egg in real life. While you could play honestly and follow along, it's much easier to just click to continue and lie to your digital friend. Scripted sequences are not the only design choices to think about. Checkpoints and quick saves can support teaching through choices. In the time mage, players are given options that may save their loved one in-game. One very important mechanic is the ability for players to revisit major decisions. These checkpoints help players think about what went wrong in their previous playthrough and try again. Oh no, it's bad ending, but why? Educational visual novels have a dark secret. The romance has gone missing. Where's the romance? Romance is the 5th most popular visual novel category on VNDB, which is a database for visual novels. Yet, romance is seriously underrepresented, with only 4 games out of the 31 played that actually utilized romance in the learning experience. Romance can play a major role in motivation in learning and is relatively unexplored as a strategy. In the game, the expression amrelato, the player's relationship with Ruka improves as they learn more words in the fictional language Giuliano. We hope that more educational visual novels will incorporate romance in the future, leading to a happy ending. And in the end, we sincerely hope that this visual novel route to learning leads to better design, better presentation, and better interactions in educational interactive narratives. Thank you for listening to our presentation, and we'll be happy to answer your questions here or even on Discord.
Many thanks, Jane-Lane. We have time for a couple of questions if we get them. Let's see. There was a bit of an exchange between Renata and Adrian on the chat, but I don't know if any of that can be turned into a question for you. PJ Lee has a question. You can unmute yourself and simply ask.
Hi. So I noticed that you talked. First of all, thanks for the presentation, and I noticed you talked a little bit, had a big emphasis on romance at the end there. So why is it important to educational visual novels, and how do you relate it back to the educational aspect of all of this?
Ooh, good question. So I think romance is very underutilized despite being a popular visual novel subgenre. It's the 5th most popular tag out of over 2,000 tags by user votes on VNDB. There are only 4 other tags that were more popular, such as ADV, which was #1, male protagonist, which was #2, protagonist with a face, which is #3, and multiple endings, which was #4. One could argue that those are technically features seen in visual novels and could not be considered subgenres, unlike romance. So it's a subgenre that's popular within the community. And to answer the second question about how it relates to the educational aspect, romance is a good complement to the teaching strategies we identified in the presentation, in the paper. It can be a good form of motivation for the player, and the gradual progression of romance can mirror a player's progression in learning, similar to how narrative progression can reflect the learning progression of the player. Romance could also offer a narrative reason to care about what we're learning, whether it's to impress a romantic love or to learn how to communicate with your player. Did I answer your question?
Yeah, I think you answered my question. And I have a follow-up, but first of all, like, what exactly is ADV, and can't romance kind of just be a distraction? Like, doesn't it have the ability to take away from the educational outcomes and kind of lead to extraneous cognitive load and things that are unrelated to learning? Can it like be a distraction?
Mm-hmm. So for the first question, according to the visual novel database and RenPy, the definition of ADV is basically like a style of presenting text. So in ADVs, the text box is usually covering a portion of the screen, which is usually at the bottom of the screen. And to answer the second question, so yes, romance, like any other design element, can be misused and can take away from the learning experience. However, I do think that romance in educational visual novels can be used appropriately and produce favorable outcomes. A little disclaimer, our taxonomy does not measure or evaluate the effectiveness of any strategies or design elements. But that being said, it can still connect these elements to existing educational theories and the player experience. It would also be nice to see as future work.
Janelyn, I thank you for being so clear and so brief, but we need to move on to the third talk of this session.
Thank you.
This is going to be a short one, meaning only a 10-minute presentation and questions combined. In this case, we have a talk called All Good Things Come in Threes, Assessing Student Design Games via Triadic Game Design. The presenter should be the Giovanni Troiano, even if it's a video. I hope some of the authors are present so that they can take questions. Otherwise, well, we will move on to the fourth one. Renata, please.
Hello, everyone, and welcome to this virtual FDG 2020 presentation. My name is Giovanni Troiano, and today I'm going to show you that all good things come in threes. So just briefly, the context. We implemented a curriculum that we developed together with teachers in Boston for integrated learning of computational thinking in STEM. And this curriculum is a game-based constructionist curriculum where K-12 students design serious games for other younger students to play and learn about climate science, and they design these games in Scratch. The idea is that through game design, they learn about climate science and systems thinking. And underlying is also the learning of computational thinking as they program in Scratch, which is essentially the meaning of computational thinking. Mostly is understood as thinking in terms of algorithms that can be communicated to machines and that machines can use to solve problems. But that's not the scope of this work. We're not going to look at computational thinking. We did that in previous work, and that's also been done massively in the literature. Instead, in this work, we look at what games do students make, and how do we make sense of these games as assessment tools eventually. So do the games, the kind of games that students design, have an impact on their learning outcomes? Well, we don't know that for sure now. It's still like a big question mark, but we're taking a first step trying to make that understanding a little more systematic. So we wanted to score these games, but not scoring really in the sense of giving them numbers, right? Like a 3 or a 2 or an A or a B, but more like trying to understand what constitutes a balanced game. And so how we could approach the problem of uncritical relativism that we have in constructionist learning, which was pointed out by Gordon in 2009, the idea that if everything is legitimate in learning, how do you separate what's good from what's bad eventually? How, for that matter, how do you guide students effectively, right, if everything is legitimate? So we try to take a first step, as I said, at systematically assessing these games, and we use the triadic game design because the framework seems to be favorable, because students design serious games about climate science, and the triadic game design is framework that has been developed especially to assess serious games. And it's based on 3 constructs, 3 basic dimensions, if you will: reality, meaning, and play. So the assumption that every game has, to a certain degree, reality, meaning, and play elements, and reality is, connection with between the game world and the real world. For example, if the game has a car, there is a car somewhere in the real world that represents an object that's present in the real world. For meaning, it represents the underlying message or the educational message that the game wants to have or accomplish with their players. And play pertains the game design elements, so the aesthetics, the gameplay mechanics, the challenges that players go through. For instance, is it a game where you need to solve puzzles? Then it would be a puzzle game. Is it a game where you shoot the targets? Then it would be a shooter game, right? So the method that we used, essentially, first of all, we assessed 391 games, which were developed by dyads of students over 3 years of curriculum. So the games are about climate change, as I said, and we used the triadic game design as our assessment framework. So rather than scoring with numbers, we created this set of metrics with minus, equal, and plus, which express how balanced within the game design one of these 3 elements of the triadic game design is. So, for example, if reality of climate science would be poorly represented, then that would be a minus. And if it was well represented, it would be a plus in our coding scheme. So we did 2 codings. We coded the game genre using the game genre framework proposed by Heinz and Lowe in HCI. And then we looked at balanced and imbalanced games via the triadic game design and used consensus in our coding. So we did multiple rounds of coding to reach consensus among the 4 people who assessed these games, which were 2 experts in HCI and game, 1 expert in serious game design, and 1 expert in education of climate science. So the majority of the games, you can see as a result, were clicker and Pong games, very popular among students, which is interesting because it's 2 popular games from 2 different eras. Pong is from the 70s. Clicker games are very now. So that's interesting to observe. The results of the triadic game analysis tell us that the majority of the games we deemed as imbalanced. And that should not come as a surprise because this constructionist game-based curricula are very experimental. So this tells us that, first of all, designing serious games, it's not an easy task and it may be really hard for kids. And second, that they might need more support from their teachers or maybe a longer time to be able to develop their games coherent in terms of game design, or high quality, so to speak. So in terms of discussion, I said already that the influence of popular games is observable and evident. For example, Pong game influenced the albedo Pong game, and that's consistent with previous literature. For instance, Kifai in 1998 observed the same thing, and that's also consistent with literature in psychology and learning in general, which tells us that the primary mean of learning for kids is by mean of imitation or mimicking things that are made by other people. So that sort of seems to facilitate game design to a certain extent. Another result that we observed is that different climate science reality can lead to different systems complexities. For example, Albedo Pong, the game on the left, has a much less complex underlying system complexity than the government simulator, the game you see on the right side. However, that doesn't mean that one game is more effective at communicating climate science because the underlying system is more complex. In fact, we thought Albedo Pong was much more effective at conveying climate science than government simulator. And how did it do that? Well, it did through procedural rhetoric. So basically, it mapped the metaphors, it used metaphors, right, embedded in the game mechanics to teach players about the ice albedo feedback. The ice paddle is representing the polar ice. The ball is representing the sun ray that when touch the surface of the ocean, shrink the ice. And so that's very clear, the metaphor there. It's very directly represented. Whereas games like Pet Earth would use reverse psychology, where the players are asked to feed planet Earth and wash it and give it a shower, but then they soon realize that by abusing resources, they're actually doing not a favor to Earth, but damage, and then Earth will destruct. So these are some of the strategies that students used to convey meaning, whether consciously or unconsciously. And last but not least, they used often default or custom aesthetics to design the aesthetics of their games. So default aesthetics means that they would only use the sprites from the Scratch library. Does it mean that a game that uses only default aesthetics is imbalanced? No, but this could be used potentially as a heuristic that could signal to a potentially balanced or imbalanced game. And so with that, I conclude my talk, and I want to invite you to visit buildingsystems.turk.edu to know more about this project, and I'm happy to take your questions.
Okay, so are any of the authors present currently online or in the chat? Because I think their being ready to take questions was a lie, and we cannot rely on them. So I don't see any of the names listed here among the authors in the chat. So although I understand Jonne wanted to ask a very interesting question, and I had one of my own, I think we should better save time and give a little more attention to talk number 4, because I'm sure that the author of that is actually present. So maybe we can have one more question for her. The 4th paper in this section, and the last one for this conference, is a short paper called I Do Not See Color, Characterizing Players' Racial Attitudes and Experiences via an Anti-Bias Simulation Video Game. The two authors hail from MIT, and Danielle Marie Olson is the speaker, together with D. Fox Harrell. So Danielle, please take it away. I think it's a video, by the way.
We introduce our short paper, I Don't See Color, Characterizing Players' Racial Attitudes and Experiences via an Anti-Bias Simulation Video Game. This research was conducted at the MIT Center for Advanced Virtuality, directed by Professor D. Fox Harrell, PhD. We thank the National Science Foundation, Ford Foundation, MIT Abdul Latif Jameel World Education Lab, and the international chapter of the PEO for their support of this research. The tragic deaths of George Floyd, Breonna Taylor, and Ahmaud Arbery have sparked global vocal expressions about systemic racism and abuse of power in the last several months. However, it's critical to acknowledge the work of scholars, communities, and activists who have been advocating for racial justice and Black liberation for hundreds of years. Although the topic of the work we will be presenting today may seem especially relevant to the current social background, this is not just about this moment. Anti-racism work is a lifelong commitment and cannot be abandoned as an urgent call to action within and outside of the academy beyond this current moment in history. Video games that address racial discrimination have risen in popularity recently, coinciding with the rapid development of the field of serious or impact games. While much work has focused on understanding the efficacy of these systems as interventions to reduce racial bias, there's been less attention paid to how individuals' prior physical world racial attitudes influence their experience as such games about racial justice. Foundational theory and collaboration underpinning this work was conducted with the Engaging, Managing, and Bonding Through Race, or EMBRACE Lab, directed by Dr. Rihanna Elise Anderson from the University of Michigan. EMBRACE is a culturally specific and evidence-based intervention designed to reduce parent and adolescent stress, improve familial psychological and physiological well-being, and improve adolescent academic engagement. The study presented in this paper examines the relationships between pre-K through 12 educators' colorblind racial attitudes, ethnic identity development, and how they experience and interpret a video game simulating a discriminatory racial encounter in a classroom setting. There is a lack of research characterizing the ways in which individuals' physical world racial attitudes may exist as barriers to transformative learning in serious games addressing racial issues. Developers cannot consider entire racial groups to be ideologically homogeneous. They will not all interpret content in the same ways. So we must consider how physical world ideology shapes digital world interpretations and behavior. The video game developed through this work was grounded in social science theory on racial and ethnic socialization, or RES. RES describes the process through which children learn about race, both directly and indirectly. Theory emerging from RES takes into account how different lived experiences and socialization results in different ways of appraising racial events and thinking about racial issues. RES scholars have found colorblindness to be the most prominent socialization strategy across racial and ethnic groups in the US. Color blindness is the myth that race does not matter within a society that continues to perpetuate racial inequality and injustice, and that one does not see race. Given that players project certain characteristics between their physical world identities into the virtual space, understanding how players' racial ideologies, such as colorblindness, persist within virtual spaces can help game developers address how they may be challenged by serious and impact games designed for anti-bias interventions. This research used a system called Passage Home, an interactive narrative video game which uses the racial encounter coping appraisal and socialization theory to simulate a discriminatory racial encounter between a Black student and her white teacher. Although Passage Home was originally developed and studied as a virtual reality experience, due to COVID-19, it was adapted into two web-based game formats, a 3D graphics-based version and a text-based version, which were tested in this study. To answer the aforementioned research questions, after playing through Passage Home, players completed several surveys to assess their in-game attitudes and interpretations, game experience, and to capture information about their physical world racial attitudes and ethnic identity development. We will briefly review the validated survey instruments used in this research. Two modules of the Game Experience Questionnaire, or GEQ, were used, the in-game module and the social presence module. The multi-ethnic identity measure is a tool that has been used in dozens of studies producing reliable results across ages and ethnic groups. It produces a score across two factors: ethnic identity search, which is a developmental and cognitive component, and affirmation, belonging, and commitment, an affective component. Finally, the Colorblind Racial Attitude Scale, or COBRAS, was used. COBRAS produces scores across three factors: unawareness of racial privilege, which are the social, political, and economic advantages that benefit white people over non-white people; unawareness of institutional discrimination, which are the implications of institutional forms of racial discrimination and exclusion; and unawareness of blatant racial issues, which are general, pervasive racial discrimination in society. The 37 subjects who participated in our study received an online link directing them to a website for either the 3D graphics-based or text-based condition of the game, which they were randomly assigned to. After playing through Passage Home, they were directed to a website where they completed all of the online surveys. According to the Institute of Education Sciences, about 76% of K-12 U.S. public school teachers were female and 79% were white in 2017 to 2018. We sought to reflect these majority demographics in our study population. This was indeed reflected in our study population, of which 81.1% of participants were female and 64.9% were white. To summarize the key results of this research, players' colorblind racial attitudes and ethnic identity development were indeed related to how they perceived characters in the game and their in-game experiences and social presence. The following statistically significant correlations emerged from analysis. Competence, or players' feelings of skillfulness and success in the game, was positively associated with unawareness of racial privilege. Negative affect, or players' feelings of boredom and monotony in the game, was positively associated with unawareness of blatant racial issues. And players' feelings of empathy towards Mrs. Smith, the NPC who was racially biased towards Tiffany, the PC in the game, was negatively associated with ethnic identity search and positively associated with all three colorblind racial attitude scale factors. Perceived competence of the player character, Tiffany, was negatively associated with unawareness of institutional discrimination and negatively associated with unawareness of blatant racial issues. Finally, perceived unfairness of the non-player character, Mrs. Smith, was negatively associated with all three colorblind racial attitude scale factors. To summarize, players with unawareness of racial privilege, institutional discrimination, and blatant racial issues may fail to recognize the racist nature of the encounter, find the game boring or tiresome without context, empathize more with the racist non-player character, and regard the target of racial violence as incompetent. Serious and impact game developers should recognize that players' racial literacy and socialization will shape their game interpretations and experience. To attend to differences in players' racial literacy and socialization, game developers should consider a spectrum of intensity to the racialized content presented in narratives, contextualizing the scenario within societal realities of racism, connect the individual level to the structural level with regards to racial discrimination, and finally, be critical in the design of game mechanics, reward, and penalty systems to not be misleading about the realities of racial injustice. Future work is underway to increase our sample size and work with additional populations, including Black students in partnership with the Embrace program, and to modify the game to study it in international contexts. We hope that this work can support game developers and scholars who seek to use the imaginative potential of serious games to advance racial justice and equity locally and globally. Thank you for your attention. For more information, please visit virtuality.mit.edu.
Many thanks, Danielle. And I saw that you already started to reply some of the questions that you received in the chat box. Do you feel like they require further elaboration?
Just to answer or recount the questions, just to make sure it's accessible to everyone. The first question was VR as a key component. So originally the game was designed as a VR experience. We made sure to use mobile VR-based experiences to make it more accessible. It's a really great point about barriers to access. We designed it on iOS and Android devices and used plastic head-mounted displays, which are about $10 a piece. And we got funding to actually have enough devices for the community-based intervention we're going to be working with. So that's a lot less expensive and lower barrier for those interventions in the communities. However, because of COVID-19, as I mentioned, we adapted the exact same game into two web browser-based formats, which were the 3D graphics-based version and the text-based version. The reason why we decided to do this is because we got some feedback around like, were people interpreting it based on just like the visual representations of the characters? So in the text-based version, I want to be clear, we made sure to describe the identities and try to describe some of the environmental cues that were used in the 3D version of the game. And then the second question was around just division of based on condition. So yes, the 37 participants were divided across the two. And then personal conclusions from research. I love this question. So I think, well, as I mentioned in the paper, there's a lot of kind of buzz around saying, let's try to use games, serious games, to reduce racial bias. You know, it's an honorable goal, but really, one, racism exists at so many different levels, and VR can only impact some of those levels and to some extent, right? The second piece is that we really can't assume that regardless of the racial or ethnic group somebody belongs to, that we've all been socialized the same way, right? I could have somebody that belongs to my same racial or ethnic group that's been socialized to, you know, not regard racism as an issue in 2020. So just because we belong to the same demographic group doesn't mean we have the same ideologies, worldviews, or thoughts about race, and we don't have the same racial literacy, right? So if I have the same sort of discriminatory encounter as somebody else, they might not interpret it the same way. So rather than just focusing on demographic category and assuming that literacy, the work is trying to get us to a point where we can understand how those physical world socialization factors will be barriers to those interpretations in games.
Everybody seems to be very, very happy with your answer and with your paper, considering it a great contribution and great critical work on the assumptions around serious games. We still, thanks to the previous presentation, not having presenters, we still have time for an additional question to Danielle, in case somebody has any further curiosities or questions. The chat is silent and I don't see any hands raised, meaning that it is time to wrap this up. Danielle, thank you, and all the other speakers also thank you for the great session. I'm sorry for blacking out due to a blackout, but I'm back and we managed to conclude this. Thank you, Renata, and all the other chairs. If you are free and if you want to, I think there's there's another meeting in room 1 with some closing statements from the chairs. So thank you, everybody. It's been a good ride, a bit exhausting to do it online, but I hope you all got inspired and informed. See you in the next occasion, I suppose. Ciao.